Good day, everyone. So today we shall be diving into processing methods, meta processing, how we can process methods to get different products that are made of metals. So in industries, molten metals, when we say molten metals, metals that have been melted, have been heated. So molten metals are cooled and then mechanically shaped. So it's only when they are melted that you can put them into shape. Now there are steps we need to take after metal have been molded for them to be shaped into the desired um, outcome. So these steps impart metal mechanical properties. We need to know some of the properties of this metal as well for us to determine the kind of shape we want to get. All right. Now, there are certain things we have to talk about, we have to understand. We need to know what metal is. We also need to know the structure of metals as well as the properties of metals. Of course, when we say metal, metals are materials that conduct. They conduct heat and they conduct electricity. Okay? We shall also be looking at the structure, the atomic arrangement of the metal structure, okay, as well as the property. So there is a word I would like to bring in today, and that's grain. When we talk about grain are portion in metals. When you look at metal with a microscopic object, these spaces here, these regions here are known as grain. Grains are region where atoms are located, okay, where atoms are located based on their uniformity or their similar properties. So all these spaces here, they are called grains. So every metal is made up of what? Grain. And this grain can either be big or, or small. Like this is a big grain. You can see this portion now, all this is a type of metal with larger grain. Okay, so it has bigger grain where you have atom in each of the grain. And this line that demarcate each grain from another is known as grain boundaries. All right, now we're saying grain size effect. What is this effect of the size of grain in a metal on the melting or heating of metal? It has been verified that when metal has a bigger grain like this, when they have bigger grain and you subject them to heat, when you subject them to heat, they can easily be bent. In other words, they are ductile. Okay, when we say metals are ductile, is the word here. When we say they are ductile, that means you can easily bend them. Okay, you can easily bend them, but they are not strong. Okay, so metals that have bigger grain are not strong. Okay, but they are ductile, you can easily bend them. But metals that have smaller grain are strong, but they are less ductile. And the reason this is so is because when you have a smaller grain, when the metal has smaller grain and you tend to bend this metal, because of the fact that the grains are too small, they are too closely packed to each other, no space. It will be difficult. It will be difficult for such metal. Okay, it will be difficult for such metal to be bent easily because of those too much grain boundaries. The grain boundaries is standing as an obstacle to bending metal with smaller grain. Okay, however, for metal with larger grain, their grain boundaries are larger and it makes it easier for the metal to be bent. And when they are bent, we say that dislocation has occurred. We have succeeded in dislocating them. So grain size have effect on the uh, the nature or the properties of metal. All right. Now we have of course quenching and hardening. We are looking at processing of metal. If you want to process a metal, of course, you have to melt it to be in a molten state. Now, when you have melted it through heating, there is need to cool that metal before you can work on it. So the rapid cooling is called quenching. Okay. Historically, quenching is also was done using biological fluid. Okay, after you have heated it, just put that metal into a biological fluid and rapidly it will cool off. Okay, but the effect of quenching is that when the metal have been cooled down or quenched, I mean the hotness have been quenched, then it will now become hard. But in this case, it will be hard at the same time brittle. Brittle means that it can easily break, okay, until you further treat that metal. So quenching has its own consequence or demerit. It easily cause breaking in metal. And today, quenching can be done using either oil or water. Sometimes salt water solution are also used to speed up the quenching process. However, whatever method, whether the old method or the modern method, the metal become brittle. So because of this demerit, another method was adopted called tempering. Tempering is gently heating and slow cooling. Okay, when you are gently heating a metal and gently cooling it, it gets stronger and it reduces breathiness. Okay, and also retain its hardness, because the essence of quenching is for you to make that metal to become hard again. All right. So when you do it gently, which is called tempering, when you temper a metal instead of quenching it, it make that metal to be stronger and to reduce breathiness. All right. So now, after a metal has been molded, that is heated, you can now begin to uh, shaping. You can now begin to shaping it. That is code working on it. Code working is the process of shaping a metal to a desired shape you want. Okay. So when you are code working on a metal, gradually, it helps in preventing dislocation movement. When we talk about code working, that means you do not work on that metal when it's still very, very hot. Okay, you allow it to cool at room temperature, not totally cool like um, below room temperature, like 20-25 degrees Celsius room temperature. You begin to what? Begin to shaping it. And you can practicalize this by getting a paper clip. This is a paper clip here. You keep turning this paper clip, keep turning it. As you turn it and twist it and twist it and twist it, a point will reach, you won't be able to twist it again. In fact, if you make an attempt to twist again, it will break. It's telling you that that is the maximum twist you can take. So, code working helps in preventing dislocation movement when uh, um, ductility is taking place. All right. Now, let's now talk about alloys. Alloy simply means mixture of two or more metals. So alloy is just the blending of metals. Also, it's a material made by melting one or more metals with other elements, right? And this process creates materials with enhanced properties. When you combine two or more metals together, it enhances the property of the new of the alloy. Okay, the new metal made called alloy. So let's see some of the example of this alloy. We have what we call the aluminium alloys. Okay, so aluminium alloys, example of this, we have the AA8000. Okay, this is used for building wires. We also have the ALLI alloy, that is made up of aluminium and lithium. So the combination of aluminium and lithium is another type of alloy. We have the ANICO. This is combination of aluminium, nickel, and copper. We also have the duralumin. This is made up of copper and aluminum. So all of these are alloys that are made up from aluminum and other materials. Okay. Then we have other aluminum alloys like the magnesium. This magnesium is combination of aluminum and 5% of magnesium. We have the magnus. This is combination of magnesium oxide and aluminum. And we have the NAB. The NAB is combination of aluminum and 7 other metals. We have the salumi. The salumi is an alloy of aluminum and silicon. Okay. And we have the zamak. Zamak is made up of zinc, aluminum, magnesium, and copper. Okay, so these are some examples of alloys of metals. Now let's talk about properties of metals and that of non-metals. You have been able to see that metals have grain size. They can be bent. That means they are ductile. Okay, you can shape in them through woodworking. Now let us see some of their properties. Number one, metals are strong, malleable, and ductile. Okay, that means they are strong, they are hard, and they can be bent as well. On the other hand, non-metals are brittle. These ones are not strong, they can easily break. Another property of metal is that metals react with oxygen to form basic oxide, while non-metals react with oxygen to form acidic oxide rather. So when you combine a non-metal with oxygen, your result will be acidic oxide. When you combine a metal with oxygen, your result will be basic oxide. Another property of metal is that they are sonorous in nature. That is, they make loud sound. They also shine when you polish them. Okay, so they can give you a shiny surface when you polish a metal. On the other one, when you polish a non-metal, it will give you a dull look. It does not shine. Okay, it does not have a reflecting surface, and it has a dull sound. Unlike metal that have a very loud sonorous sound. Then another property of metal is that they have high melting point as well as high boiling point, while non-metals have low boiling point and low melting point. Metals are good conductors of electricity and heat, as we said from the beginning of this lesson. On the other hand, non-metals are poor conductors of electricity and heat. And then metals are actually solid. At room temperature, they maintain their solid state, except mercury. Mercury can be in liquid state even at room temperature. Well, for other metals, at room temperature, they are solid. But when you subject them to heat beyond room temperature, they become liquid. On the other hand, non-metals can be in solid form, liquid form, or gaseous form at room temperature. And then metals have high density, while non-metals have low density. Metals form positive ions, but non-metals form negative ions except hydrogen ions that form positive ions. Every other non-metals form a negative ion. Okay, let's talk about some of these metals and non-metals. For metals, we have calcium, potassium, lead, copper, aluminum, zinc, and lithium. While some of the examples of non-metals are sulfur, oxygen, chlorine, hydrogen, bromine, nitrogen, and helium. So these are some of the examples of metals and non-metals. Okay, so these metals can be useful for. So we use metals to make jewelries because of the fact that they have shiny appearance and they are hard. So they are used in making jewelries that we put on as ring, as earring, as necklace to adorn ourselves. Metals are also used for construction purpose. Okay, for example, metals are used in making scaffolding and also in making bridges. We use metals in making our pans, okay, because it's a good conductor of electricity. Our frying pans, our cooking pots, they are made up of what? Metals, because they are good conductor of heat rather, okay. So they are perfect for cooking utensils. They are good conductor of heat. We use metals in making cables, okay, because they are ductile and we can bend them. So and also because they are good conductors of electricity, we use them in making electrical cables. We also use metals in making bells because they have sound, sonorous quality sound, make them suitable for making bells. Okay, now that we've talked about the uses, let's talk about the uses of non-metals. Just two of them we want to mention today. We use non-metals in making insulation. Okay, insulators are material that do not conduct electricity, like this. This is an example of insulator. So we use it in insulating materials around wire. You can easily hold wire even when current is flowing through it because it has been covered with insulators. Okay, so all these that are holding this wire are known as insulators, so that when you hold it, it will not electrocute you because it does not conduct electricity. And then we use non-metal in making the handles of frying pan. You know, when you are using a frying pan and the handle is not made up of insulator or non-metal, you can easily hurt yourself because the heat will have transferred to the handle. This handle here now is made up of an insulator, a material from non-metal. So it's ideal for the handles of pots, frying pan, and so and any other cooking utensil we use in the kitchen because they are poor conductor of heat, so that it will prevent our hand being burnt. All right, so we are going to be drawing the curtain here. I hope you have learned something from the processing of metal today. Thank you for watching and have a good day.